Still in 10.5, looking at the comparison test. We've used something similar to this before, but it says if you have two series, they're going to call them A sub k and B sub k, and they're positive terms. Here are the two things. If 0 is less than A sub k is less than B sub k, so A sub k is always smaller than or equal to B sub k, and we already know that the summation of B sub k converges, that means A sub k converges. Think about it. If A is always smaller than B, and I know B converges, then A has got to be smaller. He's got to converge too. And the other way says, if 0 is less than B sub k less than or equal to A sub k, and we know that the summation of B sub k diverges, so B sub k diverges, but A sub k is bigger than that. So that means A sub k must diverge. And there is a proof there in the book for you to read through. And we'll go on to example 3. So the trick here is to compare it to something that we know. So part A says the summation k equals 1 to infinity k cubed over 2k to the fourth minus 1. So if I just look at the k cubed over 2k to the fourth minus 1, I could say that it is similar to k cubed over 2k to the fourth. That little minus 1 at the bottom is not going to do much as we go out to infinity. But that's equal to 1 over 2k. Okay, so think about that. What about that series? The series 1 over 2k, that's the harmonic series with a 2 in front of it. It diverges. Okay, so all I've got to be able to say is that my original series is larger than that. So let's start out with 1 over 2k to the fourth minus 1 is definitely larger than 1 over 2k to the fourth. And then if I multiply both of those through by a k cubed, I would get k cubed over 2k to the fourth minus 1 definitely greater than k cubed over 2k to the fourth. But we know that that one is 1 over 2k. So, since 1 over 2k diverges and the series they're asking us about is larger than it, it has to converge as well. So therefore, the summation k equals 1 to infinity k cubed over 2k to the fourth minus 1 diverges by the comparison test. Alright, so let's go to part B. Part B, the summation is k equals 2 to infinity natural log of k over k cubed. Okay, so let's look at that one. Now, the natural log of k is less than k. If my k is greater or equal to 2. So that's why we're starting at 2, because we've got to make sure that this is going to work. So I'm going to start out with the natural log of k over k cubed is definitely less than k over k cubed, which that is equal to 1 over k squared. That guy is a p-series, and the p-series says if the p is greater than 1, it converges. Well, the p is 2. 2 is greater than 1, so the series converges. Now, since that series converges and the one we're discussing is smaller than that, I can then say, therefore, the summation k equals 2 to infinity natural log of k over k cubed converges by the comparison test. So you're comparing it to something that you can figure out its convergence on. The next thing is the limit comparison test. And it's a little bit different. It still has a limit in it. But again, you're starting off with two series, two summations, a sub k and b sub k. If you take the limit as k goes to infinity of a sub k over b sub k, and you get that answer. Number 1, answer is L for limit. Number 1, if the L is between 0 and infinity, they either both of those converge or both diverge. So what you're going to do is you're going to compare it to something. You're going to get a number, and then you're going to say, oh, that something converges, so that means the one I started with converges. And then likewise, it goes the other way. The second part is, as long as you're less than infinity, but if you get an L that actually equals infinity, oh wait, I forgot number 2. I was jumping to number 3. If L equals 0 and the summation of b sub k converges, then the summation of a sub k would also converge. And then the third one, is going to be if the limit actually is infinity, and you know that b sub k diverges, then a sub k diverges. So if you actually get a number, then the one in question does the same thing as the one that you compared it to. They either both converge or they both diverge. If you get 0, then you've got to look at that b sub k and decide, does it converge? If it does, then a sub k converges. If you get infinity, then you look at b sub k and you say, does it diverge? Because if it does, then a sub k diverges. And we'll do example 4 in just a minute. I think I'm going to give you the guidelines. They're at the end of the section. But the first thing you always want to check for when you do these, the divergence test. So I'm going to put test order. First thing I would look for is the divergence test. If that doesn't work, then I'm going to go down, I'm going to look to see, is it a special one like a geometric or a p-series? Or does the integral test work? Oh, not integral test, that's not next. Telescoping. Then, if it looks like it's something you can integrate, then you try the integral test. After that, if you see factorials, or k to the k, or a to the k, this is either going to be a ratio test or a root test. Okay, and then after that, those aren't working, then you're going to go to your comparison tests. And so I'm going to have comparison or a limit comparison. So that's the order you should look at things. It's not always the right way, but it helps to organize your thoughts thinking of things that are going to work. So that would be the order I would look at them.